Today, we're still with the normal distribution. Does anyone remember what does the normal distribution look like? It's the bell-shaped symmetric curve. So we're still working with this, and actually for most of the class, we're going to be dealing with the normal distribution. Okay, we'll look at a few others. Mean, median, mode are all the same. And then we use the mean and the standard deviation to analyze it. So let's go ahead and jump into our first example. And again, we're going to use our numworks calculator. I'll come back over to this one. And just remember, the tool we're using for all of these sections is the distributions. So we'll start off by going to the distributions. Back it up. Remember, we have these choices. Chapter 5 was all done with the binomial, and then Chapter 6 is all going to be about the normal. And when we go forward, we'll be coming back to the normal very often. Occasionally we go back to binomial, but the normal, because it's that continuous distribution, that's the one we're going to be using extensively. Okay, so again, we'll do this one by looking at some examples. So it's kind of learn by working through the problems, learn how to use the tool, the app within our calculator to answer questions. Good morning. And through that, as you work through the homework, you will see how the concepts apply. Okay. So remember, the z-score is a standard score. There's a formula to get at it, but it applies, the z-score applies to what kind of a normal distribution? A regular one or a standard one? Thank you. Yes, it's the standard. So, and there's a lot of information when we see that word standard normal. You just think, okay, that's the standard one, right? But when we have a standard normal, we can use z-scores. So we'll put this up here. And sometimes in the question, they'll mention that they have the standard normal. What does that mean about the mean? Or what is the mean in a standard normal? It's always the same value. It's always 0. How about the standard deviation of a standard normal? It's always good. So these are the things you're going to have to remember, because when you get into a question and it says we have a standard normal or we're looking at a z-score, those are the things we have to know. Because what's the first thing we have to put in when we're using our normal distribution? The mean and the standard deviation. So the next series of questions, we're going to be looking at the standard normal. So I'll put in my 0 and my 1. When you first open up your calculator, those are the defaults, right? So for these first questions, you could just stick with the default, but also remember that, because whenever we're dealing with z-scores, these have to be the mean and standard deviation. Oops. Then we come to this part. We'll leave it there for now. Okay. All right, so let's look at a question. So this one, we're just given a normal drawing. We're asked for the z-score, right? And we're given the area. Now, in the past, we were given the z-score and asked to find the area, either below that z-score or above the z-score or between the z-scores, right? So in this case, we're given the area. Is that going to cause a problem? Well, it could. We didn't know that in our input, we arrow over, we can actually put the percentage in, the probability, the area. We can actually enter that, and it will give us the z-score. Okay. The thing we have to make sure is we're using the right tool. Right? We have a less than, a between, and a greater than. Which of the tools are we going to use here? The less than, to the left, right? I mean, it's all visual, but you got to make sure you're using the right one. And then what are we going to put in for the area? 0.1039. And again, we could, while you're doing this, you could actually, this is a working calculator here. So you could be using this. It's just, again, the small window doesn't look real good, especially in the back. Okay, so we've got the right one. Again, on our last lesson, we were putting in the values here that x was less than a value. This time, we're going to be putting in the percentage. So we just enter 0.1093. Okay, I had the 9 right, but 0.93. We hit execute or OK, whichever button you want to push. We get the picture, and doesn't that look like the graph that's on that page? And here's our answer, negative 1.23. Why is it negative? What's its relationship to the mean? It's less than 0, right? Less than the mean. So z-scores are always going to be negative if we're to the left of the mean. Those are the types of things. Remember, the calculator is doing all the formulas, all the calculations for us. What we would do, maybe we'd go look it up in a table, but this is doing it all for us. So, but take the time to take a look and notice all these things, because those are the concepts that will help you with some of the other questions. So our answer is simply negative 1.23. And again, when you're doing the homework, read the question for how many decimal places they want, the rounding, and so forth. So far, so good. Not too much different, right? We're just putting in the input that we have. We're just putting it in the other slot, right? We're just putting it in over here. But pay attention, because as we go forward, you'll get questions that are a mix of them, and it's easy to mix it up and you put it in the wrong spot. You know, had I put this over here, I would have got a different answer, right? Let's see that. What if I put this in the wrong spot? Put 1.1093 here. The cool part about this doesn't look like that graph, does it? So there's an indication I must have done something wrong, because I'm supposed to look like that graph. So that's why we use this tool, is you've got both a visual of what it's supposed to look like, what it's going to look like, and you get the calculation as well. I mean, the TI-84 calculator, it's got an option to do these kind of things, but it doesn't give you the graph. And so you get a value and you just write the value down. It's wrong, but you don't remember why. Well, you put it in the wrong place or something. Here, we're going to get that. Okay. So again, the graph is going to be very powerful for us. And most of what we're going to do is all the same, except we go to the next one. Let's see. Oh, also, if you come into Canvas and use this, this will also serve as a memory guide, because I put the screenshots in the slides. So as you click through them, if you don't remember what to do, you'll at least get some screenshots that, oh yeah, I go to that place, and then I get this. And we see it here, a little bit larger. Okay. Find the z-score that corresponds to the cumulative area, 0.7936. Cumulative area. So we don't have a graph this time. We do know it's a z-score, so that means we can use a standard normal, right? What does it mean to be cumulative? Which tool are we going to use? Which one? First, second, or third? Which one of these is cumulative? The second is between two values. Now, in a sense, you're right, it is cumulative from this point to this point. But if they just say cumulative, that means from the beginning to a value, right? So where's the beginning? way off to the left. So when you see the word cumulative, they're just referring to this one. We're going to what's all to the left. Okay. And I guess you could even say this other one is cumulative from the bottom to the top. But when just the word cumulative, that's from the left to the right because of the way we do the math. Okay, so we'll use this one. And again, all we need to do is put this in as a, now it's not a z-score, it is a area. Okay, so this is the trickiest part, is you have to choose the right tool, and then you have to put your value into the right place, right? Before, it's a number that could fit there, but what we want to put in, we want to put it here, 0.7936. Okay. And then we see it's going to the left. And remember, that's 79, that's like 79%. So when you see the picture, does that look like about 79, about 80% of the graph of the curve? Yeah, looks pretty close. Okay, so you'll get a visual confirmation. And the answer we're getting is 0.8189. Notice how those numbers, if you just looked at them as numbers out of context, look very similar, but they're different, right? This 0.8189 is referring to the location down here, right? It's referring to a z-score, or as we're going to see in the next few ones, it would be a data value. This 0.7936 is actually a percentage, 79%. Okay, it's the area under the curve. So we've got to watch those things because, again, the tool is going to do it for us, but we have to know what we're doing. So again, the answer is z equals 0. I forgot what it is, but if I click here, actually, I'm writing right on top of my answer, but that's okay. 0.818. If we round it to 4 decimal places, the 7 rounds the 9 to 0, which means that 8 becomes a 9. And again, you just look for, the homework will tell you how many decimal places to round it to. So check on those things. Remember, this is not a percentage. This is the location of this point right here. Okay, and it is above the mean, so that's why it's positive. So take a look at the graph, put all those things together, and you'll catch on, and it all will make sense. Question so far? Okay. So again, today's lesson, always we're putting in for that value, the area, the percentage, we're putting that in, and then we're getting either a z-score or a data value. We'll do some with the data value here in just a moment. Oops, what happened? Oh, I got my my images out of order. I'll have to fix that later. Now, sometimes they'll ask this as find the z-score that corresponds to P8. Does anyone have an idea what P8 means? I haven't told you, so it's okay to guess. I had a guess. I figured what it was, but P8. What might that mean? What's that? Good, a percentage, and actually percentile. So a percentile is what? It's the percent, I'll go this way, from left to right. Okay, so it's sort of a cumulative percent. So it's saying 8%, right? So corresponding to 8%. Percentile, percent. So we can kind of see it's going to come from here. It's going to be down here somewhere. So I just have to remember that 8 means 8%. And so, and it's a cumulative, because percentiles always go from the left over to the right. Remember, if you get it backwards, you don't want to think this is not talking about the top 8%, it's talking about the bottom 8%. Okay, so we come in here. We still using the same tool because percentiles start from the left and go to the right. Now, do I put in 0.8 as my percentage? Exactly. That would be 80%. So yeah, be careful when you're doing percentages. It's not just one decimal place, it's two. So I want to put in 0.08. Excellent. Oops. 0.08. And it gives it, and it does that look like about 8%? Sure. I mean, it's certainly less than half. I can, because I know if I came halfway, that'd be half. So 8%, it shows it up here. And so my standard score, my z-score, is negative 1.41 if you do to two decimal places. So I click on here, shows it up there. Z equals negative 1.41. We'll do it to two decimal places. Again, just look in the homework how many places they ask for it. Usually with z-scores, they'll only do two decimal places because that's how the tables are set up. That, again, we're not using the tables because we've got the feature built into the calculator that we're using. And we get more accuracy by doing it that way. Make sense? So just watch, if you got P something, that's your percentile. Percentiles are always percent below, from the starting from the left side to whatever it is. Okay, and we're going to see some others in here. Let's see, what was this question? Find the indicated z-score shown in the graph. Again, just like what we started with, but this time, which tool do we use? We're going to the right, correct? Because that's, we're shading to the right. So we want the area that's about 4%, 4.5% to the right. So we just come and change our tool. We're going to see ones where we can also use this between. And actually, we'll do a little, I'll share a little bit of research I did previously on that. So we've got the right tool. It's going to be shading to the right. And again, just be careful. Don't put it in for X, because that's what we're looking for. What we're given is the area, the percentage. And for that one, we put in the 0.0446. Did I get that right? Yes, I did. Okay. I hit execute or OK, either one will do. And then I check. My graph looks like that picture, right? And so 1.699, maybe just rounding it to 1.70. And again, what is that? That is the z-score. So that's down here on the x-axis, 1.70. Okay. So far, so good. So again, just backwards of what we were doing previously. But I want to show you the power of this and why we do it. So first I'll show you how to get it. And then now let's take a look at what we use it for. Get rid of that stuff. Okay. So here's a sort of real world example. We've got a survey of 18-year-old males. They have a mean weight of 169.8 pounds. I think that was my weight back in high school, but haven't seen that in a while. Okay, I'd love to get back down to it. They have a standard deviation of 53.4 pounds. So remember, so it's about 170 pounds plus or minus 53, right? That's one standard deviation. Two standard deviations is a little over 100 pounds, right? So we can kind of start to visualize what that looks like. We're told to assume the distribution can be approximated by a normal distribution. So that's saying it's not exactly normal, but it's close enough that we can use the tool. Okay, so don't get hung up on that particular phrase, because you'll see that again and again. It's approximately normal. What it's telling you is, yes, we can use the tool. Okay, now the questions, we're going to answer all of these. What weight represents the 97th percentile? How about the 46th percentile? And what weight represents the third quartile? So we come back to our calculator. What's the first thing we need to do before we start putting in our percentages? Exactly. we are working with a standard normal, and now we are working with actual data. So we have to back it up and change from our standard normal 0 and 1, and we have to put in our mean and standard deviation that they gave us. Exactly. It was what, 169 point, you want to catch that? Is it 7? What? 0.8. Thank you. Okay. And what was our standard deviation? 53.4. Thank you. So that's the key part, because if you forget that part, you're going to get a z-score, not a weight. But in this case, we're actually going to get weights. Okay, so that's the nice thing about this tool. We don't have to change it to a z-score, look it up, and then change that back to a data value. So we save ourselves a lot of calculations in this part, and we see that our x-axis actually has weights, right? Here's a 200 pounds, 100. And then again, what do we want? If we're doing the 97th percentile, what does that mean? What are we putting in? 0.97, good, because it's a percentage, right? And do we want to the left, to the right, or between? Excellent. So again, just think through all those things. Since it's a percentile, we always want to the left. That's the tool we'll probably be using the most, okay? So someone who's in the 97th percentile, again, I have to look over here. This is where I put percentages. This is where I put areas, 0.97. If I put it in this X, I'm putting in a, well, you put 9.97 over here, you're like right down here, okay? I do X, and then, so 97% of the people of males, 18-year-old males, weigh less than 270.23. We could round it just, so 270 is the 97th percentile. Fortunately, I haven't gotten up to that yet, and hopefully I don't. I edge up there a little bit, okay? So that's our 97th percentile. That's the borderline. That means 97% of the males that are 18-year-old males, from the survey at least, are somewhere between 0 and 270 pounds. Probably not too many 0-pounders, but okay. 46th percentile, what do we do differently? .46, and I guess I should click down here. There's our, again, so this is a way to kind of check to make sure. And again, we just put the 0.46. And since it's a percentile, we use exactly the same thing. And yeah, there's 46% of it, 164. So that, and again, that's a little bit below the mean, right? Because the mean was 169 or something. So we're a little bit below the mean. But 46% weigh 164 or less. Okay, so we could put that in there. And this one throws us a little bit of a curve. It's not talking percentile. What weight represents the third quartile? Think back to what we were doing back in chapter 2 or 3. I think maybe it was 3. Maybe it's 2. Quartiles. How much is a quartile? So yeah, quartile is just 25. Third quartile be 75%. Very good. So again, a lot of this is coming back to our vocabulary. So third quartile is the same thing as the 75th percentile, right? So we put in the 0.75. And that looks like about 75%, so that's something about 205. So that's my target weight right now. I'm trying to get down to. And then I'd like to get a little lower, but I'm certainly not an 18-year-old anymore. So, okay. Make sense? Okay, so you can see how you can do this, and these type of things can be used for health purposes. You know what percentile you're in, and if you know. And again, we can click through here, so you can see. Yeah, okay. This is still on the high side. If I could bring it down a little bit, maybe healthier, so we could do comparisons with, well, you know, what the uh, health people are saying is valuable or what we should be doing. Okay. So we'll be using this, but I want to show you something that I added this morning. The other part, and this is kind of, think about, we're going to be using this after the exam when we get into hypothesis testing and research. With research, what we're trying to find out, and some of these questions have already been asked. They'll ask if a value is usual or unusual. Okay, usual or unusual values. With research, we're trying to get a treatment that leads to unusual values. Because if it's in the usual, that's just randomness, right? But if we can get it to where it is an unusual value, then that might mean, doesn't always, but it might mean that our treatment is working. It's doing what it's supposed to do, hopefully. So what I've worked on, when I was working on my doctorate, I had like 4 different projects, and some I got started on, and then my mentor said, well, that's either too much work or it's not going to work or something else. So I had 4 dissertation projects started, and I got them to like chapter 2 or 3 I wrote. And this is one of the things I worked on. I looked at GRE, which is the graduate record exam. Those of you who, and I hope a number of you do, go on to graduate school, typically a lot of them require you to take the GRE. There's a math version. It's kind of like a SAT, but for graduate school. So there's a math version, a math portion, a verbal portion, a written portion. But I looked at the math and actually made a math course to help improve scores. But the GRE, just a little background, the exam, the scores are from 130 to 170. So you can't score 0 on it. So that's kind of a nice thing. Even if you miss every question, you score 130. And if you get 170 is the highest you can get. The overall mean and standard deviation for everyone who takes it is 157.6 with a standard deviation of 9.9. What I was interested in looking at, because I do a lot of reading on standardized tests, oftentimes have cultural components to it where certain groups of people don't do as well. So I looked at both male and female, and there are differences of scores between males and females. And ethnicity, one of the ones I focused on was Native Americans. And the Native Americans as a whole have a mean of 147.9. So no, it's about 10 points lower on the average, and less variation, 7.5. So I was looking at what can I do as an innovation to maybe move that mean up, right? Specifically for Native Americans. I also looked at African Americans, Hispanics, Asians. Actually, if you compare to Asians, Asians had the higher scores. But so how do we get a platform where everybody is sort of leveled out? Because remember the GRE, all these people, they've already gone through a college, they're all college educated. That's why they're going into graduate school. You can't go to graduate school until you get your bachelor's degree. So these are all people who have a bachelor's, so they've taken the math. And the math itself is not much more than algebra. I think there's a little bit of trig, but there's no calculus in it. Okay. So anyway, what I want to show you is when you do research, we're looking for what is normal and what is unusual. So 147.9, so I'm going to come back here. That's kind of what we're doing today. 147.9. I looked at this, and the standard deviation was 7.5, I believe. Anyone else remember? Yeah, okay. 7.5. I'm going to show you how we use our tool. So to see usual versus unusual, that's where we actually come over and we use this between. Okay, so I'm going to look between. I'm not going to enter these. What I'm going to do is, there's a couple different ways to look at usual or unusual. One rule is 2 standard deviations above to 2 standard deviations below. Okay, that's one. The other one is 90% or 95% or 99. So we're going to look at 90%. And what does that look like? Notice it gives me the middle 90%. And so that is one way of measuring normality or usuality. That's a new word. Anyway, the usual scores are right in here. So if I get somebody, if I work with an individual and I get them to 160, they're still in the usual area, right? Because variation says a Native American testing, because again, these are specific values to Native Americans, will score somewhere between 135 and 160. That's usual. What would be unusual is to score more than 160 or less than 135, but I don't want to reduce scores. I want to increase scores, right? So I'm going to say I need something that will, on average, get people scoring better than 160. Now, in reality, I might do a pre-test, and then if I'm looking to improve somebody's scores, but this is sort of a general thing that I'm looking at. If my innovation is going to be successful, I've got to consistently get people into this unusual region. Now, we'll talk when we do it. I don't actually have to get the mean above that one because that would be hard to do, but we'll see that we're going to use this in our next one. So if this is 90%, in fact, actually, I'll come over here. Do these. This is 90% in the middle. Can anyone tell me how much is in these two sides? %90 shaded, how much not shaded? 10% or 5 on each end. You could look at it either way, and we will. So there's 5% here, 5% there, for a total of 10%. And what we're going to see, kind of looking down the road, we call that an alpha. So this would be a 10% test. We want to get into that 10%. We want to get into the unusual regions. We'll look at, we do both, this is a two-sided test. What I'd actually want to do is a one-sided test because I don't want to reduce anybody's score. That could happen, couldn't it? Stress them out or something. But I want to improve their score. So that's another type of thing. But I just want to show you that it is connected to what we're doing. And then you could do the same thing with this between. If you want sort of a little bit more accuracy or challenge, you go with the 0.95. And this is one that is typically used, a 5%. And notice that jumped it by, I went from 160 to 162, right? So I've got a little bit wider. I've got a 95%. How much are in the tails? So 95% is here. How much are in the two tails? The two unshaded regions? A total of 2.5, right? So 2.5 on each side. And this is what we'll call a 5% test because they add together. And that's what we're shooting for, is we're shooting for our treatment after some calculations to get us into those unusual values. And what we use is not just the mean, but that change, the change in the mean. And so there's some calculations behind it. Again, our calculator is going to handle all of that for us, but this is what we're looking for. In these sections, we're looking for the usual values, right? What's in the shaded region. But after the test, when we get into the next section, we're going to be looking for unusual values because we're hoping our treatment, whatever we treated them with, changes the situation, improves things. Okay, and you could even go for a 99%. That's a little bit, it's not always done, but again, sometimes after you do your research, you can say, hey, I did get there, so now I'll change it to a 99% test because that's even more powerful, right? I made a bigger difference. But usually research starts off at the 5% level. Sometimes they'll back down to the 10% level because you do your research and say, well, it doesn't show any significance at the 95, so I'll call it the 90% and say we did something. Or if you did a lot of significance, you got really out there, you could change it to the 99%, and that strengthens your results a little bit. But again, you'll see most of the stuff we'll start at the 95% level. But you will remember this tool when we go on to the next stuff. Occasionally we come back and we use this tool again to understand what's going on when we do those tests. Okay. And that's it for this section. What we're going to then, so we'll take a working break, bathroom break, or whatever you take a real break if you want. Let's come back at 10, so about 20 minutes, and we'll look at the last section in this section, which is using the same concepts, but it's for taking multiple samples. And as you get multiple samples, you'll get different means. And again, it's all coming from the same population. So there's a way of looking at that. We'll use the tool to do that. And those will be the last few questions in the Chapter 6 homework. Okay, but I'm open for questions. If you got them, take a look at your homeworks. And again, you should be finishing off Chapter 5 here pretty soon if you haven't already done it, so that you can be doing Chapter 6. The goal is by the end of this week to have Chapter 6 done, because we're already having the test on Tuesday. Okay. Thank you.